Hi everyone. So today we're going to try to finish up 11.1. So the last thing I actually want to talk to you about is something called boundary value problem. So which is different than initial value problem. Okay. Boundary value problems, just like initial value problem, basically requires some kind of condition given to you for you to satisfy the equation. So to mirror that with initial value problem, let's talk about what this is. Let's say if we're given what we call an initial value problem, basically require our solution, our general solution to our differential equation, to satisfy a given set of initial condition. And here's the important part. In this sense, initial condition at a single point. Meaning, in this case, when we have an initial condition, the initial condition would define a single point and also everything else that happened at that point, such as what the derivative would be and things like that, or the second derivative would be, or the third derivative. So initial condition would usually look like something like this. Would probably be something like y of x sub 0, y prime at x sub 0, y double prime at x sub 0, and so on and so forth. The key is that they all have the same exact x value because they all define the same exact point. And what happened to the function as well as always derivative. Boundary value problems are a little different. So for a second degree or second order differential equation, for a second order differential equation, we can require the problem to pass through two given points. We can have what we call a boundary value problem. And how is that different? Where we require our solution to pass through two given points. And these two given points are basically what we refer to as boundary. Okay? Now, boundary value are definitely a lot more difficult to do. Boundary values problems are definitely more complicated than initial value problems. More complicated. Than initial value problem. And one of the main reason why it is more complicated is because that it might not even have solution for them. While initial value problems always have a solution, the reason why, because they work out to be solving the system of the equation. And because a linear system, they usually would have a solution for that. And here's the key is that, and sometimes they don't always have solution. While initial value problem almost always have solution, boundary value problem are usually more likely to fail because you're forcing the solution set, which is kind of like a curve, to force it to go over to a specific point, and sometimes it just might not work out. Okay, now solving boundary value problem is really not the focus of this chapter, as well as a matter of fact also not the focus of this course either. We're most likely solving more initial value problem than boundary value problem, but it's definitely something that I would like you to at least have an idea of and be able to do some simple one. And one of the major reasons why it becomes complicated is because it has to go through two separate points, therefore requires us to go through two separate x value. And notice that all the initial value problem that we've done so far are very easy to do, mainly because we use 0 as our initial value, and therefore the e to the power would just go away. But in boundary value problem, we won't be able to do that because we need two different x value. So 0 is probably the only one that's easy to use, but if we already use that for one of them, then the other one we have to use something else, and that becomes the problem. So I'll show you a very basic example of a boundary value problem. Let's say given a differential equation, and we go do a second order differential equation. We can't do first order because that will only require one condition to solve for one constant. So therefore, if we have a second one, then most likely it not going to work because the equation might not go through the second point. All right, so let's say we have this equation, and I'm going to go and give you the boundary. And of course here the term boundary basically kind of like the beginning and the end of the curve. So we kind of forcing this solution to this differential equation as a curve to go through this 2 point kind of as like the beginning and the end point of the interval from 0 to 1. Let's try to solve this boundary value problem. Oops. So I'll show you why this is more complicated compared to an initial value problem. So here we're going to start with this, y double prime minus 4y equal to 0. Same as before, so therefore that means d squared minus 4 of y equal to 0. That means r squared minus 4 equal to 0, r equal to plenty plus or minus 2, so I'm going to say r1 equal to 2 and r2 equal to negative 2. So those are my two characteristic roots. All right. And so that seems pretty simple. So therefore my solution would be y equal to c1 e to 2x plus c2 e to negative 2x. So nothing seemed too difficult yet. Okay. So here where the difficulty is by plugging in the two boundary value. So y of 0 equal to 1, that one is nice. That will mean 1 equal to c1 plus c2. So that's a nice simple equation. Okay. But the trouble is the second one, y1 equal to 2. Because we don't use 0 anymore, I do have to raise it to a power, and that becomes somewhat the problem, the issue here. Okay, if I do that, I will have 2 equal to c1 e to the 2 times x, which is 1, so e squared, plus c2 e to the negative 2. So that's my second equation. Notice that the reason why it's more difficult because now these have some coefficient in front. That's now make it difficult to do. So now how do I solve for C1, C2? So well, basically what you do is you use what you know from multivariable calculus to do it. What we're going to do is what we call addition method. Okay, or you can definitely use matrices too, but here I'm probably just going to use elimination method or addition method. I'm going to take the top equation and multiply the top equation by negative e squared. So I'm going to take the top equation, I'm going to multiply it by negative e squared, and when I do that, I'm going to have negative e squared equal to negative c1 e square minus c2 e square. And I'm going to put the second equation underneath. I'm going to add these two equations together. So notice that c1 will cancel out, so now I can solve for c2. So I will have e squared minus, 2 minus e squared, that's what I meant. 2 minus e squared equal to, here I'm going to factor our c2. What I have will be negative e squared plus e to the negative 2. And now I can solve for c2. Well, c2 would equal to, I'll probably go right this way, 2 minus e squared over e to the negative 2 minus e squared. That become my C2. Yes, it's not pretty, but that's one of the issue with boundary value problem. I'm going to repeat the same process to do the second one. I could definitely plug this into my equation and solve a C1, but that's actually a lot more algebra to do than to just go through this process again. So I'm going to do this. I'm going to multiply my top equation by negative e to the negative 2 this time. So become negative e to the negative 2 equal to negative e to the negative 2 C1. Or maybe I should write it this way. Negative C1 e to the negative 2 minus C2 e to the negative 2. And we'll put a second equation underneath. And notice that this time when I add them, C2 would cancel out. So therefore, what I have is 2 minus e to the negative 2 equal to, once again, we'll factor out C1, so e squared minus e to the negative 2. And then what I'm going to do is solve for C1 by dividing to the other side. So 2 minus e to the negative 2 over e squared minus e to the negative 2. So that's my C2. And now I'm ready to write out my solution. So my solution becomes y equal to C1. 2 minus e to the negative 2 over e squared minus e to the negative 2 multiplied by e to the 2x plus c2, which is on top, 2 minus e squared over e to the negative 2 minus e squared. Okay. E to the negative 2x. So that becomes my solution. All right, so that's a boundary value problem. So notice it's definitely not pretty, but if you think about it, this two coefficients, C1 and C2, I mean, I'm writing out exact value, obviously, but, you know, you could definitely just type into calculator and have a decimal out of it, or it might actually be able to simplify even further if I really look into it. Okay, but I think what it looked like is fine. Alright, that will be it. Actually, I don't have anything more to show you. Boundary value problem was the last thing I wanted to show you in 11.1, so therefore, I guess today's video is really short. It's about 12 minutes. But I didn't want to put it into the last video because last video almost over 20 minutes, so I don't want it to make it too long. So instead, I've decided to space it out to 4 videos. So that's it for 11.1. So our next video will start on 11.2. Alright, talk to you guys later. Bye-bye.